Hello, welcome. Let's start the fourth lesson of statistics. Today we are going to talk about the topic how to visualize categorical data. Once again, at the end of the class, we will have practical examples given in Excel and Python. So far, we have been talking about numerical data, and it's very comfortable to talk about numbers, because we know mathematically how to deal with them. For example, when we investigate the price of houses in London, we obtain a list of numerical values. We can count them, add them, calculate measures of central tendency, and do other mathematical operations with the data. But what if we want to talk about other types of concepts, such as the fruit consumed in the morning for breakfast? We can try to investigate this topic and get a list of fruit names. The list will have mentions to oranges, apples, pears, bananas, not necessarily numbers. Of course, we could assign a number to each type of fruit, such as orange is set to 1, pear is set to 2, apple is set to 3, and so on. However, does it make sense to have fruits as numbers? How can we add a pear to an orange? And why will some fruit be more worthy than others? The way to deal with these values, which we call categorical data, is quite different. First, there are many examples of this type of data. For example, a survey on the gender of respondents results in categorical data. If we want to know the blood type of a sample of residents in some country, we will collect values such as A, B, AB, and O. Another example is the preferred payment method, which the respondents can say things such as cash, credit, or debit card. It is important to distinguish quantitative, that is, numerical, from categorical data. Quantitative data are numbers that represent a count or a measurement. Categorical data is a list of categories or groups. It may or may not have any logical order. For example, for the fruit case, we have many categories of fruit that are mutually exclusive. A pear cannot be a banana and an apple cannot be an orange, for example. Often we will obtain both categorical and quantitative data when we are investigating a subject. For example, when we are analyzing sales of household appliances in a store, we may be interested in recording the type of machine, brand, and model. All this data is categorical. If we are interested in the selling price of the household appliances, the data recorded will be quantitative. You can subcategorize quantitative data into discrete and continuous. Data can be continuous when they take on values in a continuous range. For example, salary, inflation rate. The data can be discrete when it only takes values on a finite or countably infinite set. For example, age or shoe size. In the same way, we can subcategorize categorical data into nominal data when there is no natural order between the categories. This happens, for example, when we talk about profession or gender. The data can also be ordinal when there is a natural order between the categories. An example of ordinal data are educational grades or preference rankings. And how do we perform operations on categorical data? The central tendency of a set of categorical variables is given by its mode, but the mean and the median cannot be defined. As an example, given a set of people, we can extract the list of their surnames. This is categorical data. We can consider operations such as equivalence, whether two people have the same surname, counting, how many people have a given surname, or finding the mode, which name occurs more frequently. However, we cannot meaningfully calculate the sum of Mary and John, or ask whether Mary is less than or greater than John. As a result, There is no point in asking what the mean name is or the median name in a set of names. The first step in the analysis and interpretation of categorical data consists of describing or presenting the data in the form of tables or graphs. There are several types of graphs and charts that can be used. Frequency tables allow you to count the frequency of each category and identify the proportion of each one in relation to the total. Let us see with an example. A painting by a famous painter was projected on a screen to a class of third-year primary students, and each one was asked to write on a sheet of paper the most beautiful color they could identify in the painting. The teacher then listed for each student their favorite color. Each student was identified by an identification number ranging from 1 to 12. We can analyze their categorical data with a frequency table. To do this, start by recording the number of times each color was chosen, that is, the absolute frequency of each color. Relative frequency is calculated by dividing the absolute frequency by the number of data points and multiplying by 100. The values are now in percentages. Clearly, the green color was the most chosen. Another graphical way of presenting this data is using the so-called pie charts, in which the sizes of the pie slices are proportional to the frequencies of each categorical value. Generally, pie charts are cut into different sized slices to show the specific percentages for each element. There are some reasons, however, not to use this type of graphs extensively. The most relevant is that humans are not particularly good at estimating quantities from angles, which represents the basis of this graph's reasoning. If you want to make comparisons between groups rather than making comparisons between each group and the whole, it is better to use a different type of chart, such as a bar chart. The bar chart is also a useful tool for visualizing the distribution of categories and comparing the frequency between them. Let us see a practical example in Excel. We are interested in political opinions in Portugal. We have a sample of 10 interviews who agreed to give us their voting intentions. In this first column, we have an identifier associated with each voter, and in the next column, we have their preferred party. In the third column, we include the list of all parties with parliamentary seats. The first step is to take the relative frequency. As we only have 10 voters, it is easy to calculate manually, but the same is not true for large volumes of data. So, I'm going to show you a way to quickly calculate frequencies in Excel. Using the countif function, we can compute the list of relative frequencies. Just enter the formula countif. Select the set of data to look for, first column, and then the set of unique data in the second column. If you do this for all party values, we obtain a frequency table. From here, it is very simple to generate the pie chart and the bar chart. Let's create our pie chart by selecting column 3 and 4 and inserting menu insert, a pie chart, icon pie. And here we have our graph. Looking at it, we immediately know that the PS has a large proportion of voting intentions, and so does the AD. It is difficult to know exactly what the proportions are. To do this, we calculate a bar graph. Let's create our bar chart, and here we have our graph. Looking at it, we know exactly what the proportions are. Finally, we give an example in Python. In Python, we can create nice charts using Seaborn and Matplotlib library, this second library being the most popular. In this example, I will show you how to create a pie chart in Python using Matplotlib. Imagine you want to see how many cars your stand has sold per brand. You first create a vector with a list of categories, such as Audi, BMW. Then, in the second vector, you describe how many cars were sold, 23, 17, and so on. The third step is to create a plot. The function pi should be called. Don't forget to use plot show function so that you can see the chart. To create a bar chart, simply change this line to call the function bar. Running the code, you will get a new chart. Thank you for watching and see you next video.